In Episode 11, titled 1.2 Compare Repositories, Data Lakes, Lakehouses, Marts, Warehouses, Silos, the goal is to clarify repository choices and the real consequences those choices create for reporting, trust, cost, and governance. The CompTIA Data DA0-002 exam often tests this topic by describing an organization that struggles with inconsistent numbers, slow reporting, or unclear ownership, and then asking which repository approach best fits the need. Repository terms can sound like marketing, but the exam is looking for practical reasoning about how data is stored, curated, accessed, and controlled over time. A good choice is not the one with the newest label, but the one that matches access patterns, governance requirements, and the organization's ability to maintain definitions consistently. When repository types are understood in plain terms, a stem that mentions raw feeds, curated reporting, or team-specific dashboards becomes easy to map to the right concept. The aim here is to make these labels feel like predictable trade-offs rather than vague buzzwords. A data lake can be defined as a repository designed for raw, varied, low-friction storage where data can be landed quickly in many formats without forcing a strict schema up front. Lakes are often used to capture data at scale, including structured tables, semi-structured formats like JSN, and unstructured content like text and images, because the priority is ingestion speed and future flexibility. This low-friction approach supports exploration and reuse, but it also means quality and meaning are not guaranteed unless additional management practices exist. In a lake, it is common to store multiple versions of the same dataset, different levels of processing, and data from many sources, which can be valuable if lineage and access control are handled well. The exam signal for a lake is often language about raw data, landing zones, varied formats, and the need to store everything even before the use case is fully known. The core trade-off is flexibility versus the effort required to make data consistently queryable and trusted. A data warehouse can be defined as a curated, structured, query-ready repository designed to support consistent analytics and reporting. Warehouses typically enforce schemas, support dimensional models, and provide stable definitions so that multiple teams can answer questions with the same logic and get the same results. The emphasis is on data quality, integration, and performance for analytical workloads, which is why warehouses are central in many reporting environments. Data entering a warehouse is usually transformed and standardized so that fields have consistent meaning across sources, and that curation reduces ambiguity when metrics are computed. The exam signal for a warehouse is often language about enterprise reporting, trusted dashboards, consistent definitions, and repeatable analysis that must stand up to scrutiny. The trade-off is that warehouses require ongoing engineering and governance discipline, and they may not accept every raw format without prior shaping. A data mart can be defined as a focused subset of data designed for one team, one department, or one business function, usually to support a specific set of reports and decisions. A mart can be derived from a warehouse or built independently, and that distinction matters because it affects trust and consistency. When a mart is a curated slice of an enterprise model, it can improve performance and usability for a specific audience while preserving shared definitions. When a mart is built separately, it can become a parallel truth source where the same metric is calculated differently, creating confusion across teams. The exam often uses marts in scenarios where a marketing team, finance team, or operations team wants tailored views with fast performance and simplified tables. The trade-off is focus and speed versus the risk of drift and duplication when marts are not aligned to a central definition system. A lakehouse is best defined as an approach that aims to combine lake flexibility with warehouse management features, so raw and varied data can be stored while still supporting stronger governance and query performance. The idea is that a lakehouse keeps the broad storage and format flexibility of a lake, but adds capabilities associated with warehouses, such as better schema management, transactional reliability, and more consistent access controls. In practical terms, this can reduce the gap between raw landing and curated reporting by allowing more structured use directly on data stored in a lake-style environment. The exam signal for Lakehouse often appears as a scenario where an organization wants to avoid duplicating data across separate systems while still needing reliable reporting and governance. The trade-off is that a lakehouse still requires discipline because adding management features does not automatically create consistent definitions or high-quality data without process. The best way to treat the term is as a set of goals, not a magical category that removes complexity. Schemas and governance expectations differ across repository types, and that difference is one of the most tested ideas in these scenarios. Lakes tend to support schema-on-read patterns, where structure is applied when data is used, which increases flexibility but makes it easier for multiple teams to interpret the same data differently. Warehouses tend to support schema-on-write patterns, where structure and definitions are enforced before data is loaded, which increases consistency but requires more upfront work. Marts often inherit schema and governance from the parent system if they are derived correctly, but they can also bypass governance if built as isolated stores. Lakehouses aim to bring stronger schema and governance controls into a lake-like storage environment, but success depends on implementation and discipline. Exam stems that mention audits, privacy, regulated reporting, or conflicting metric definitions often want the candidate to reason about these governance consequences rather than focusing only on storage cost. A company reporting story can anchor the differences by showing how the same organization might use different repositories for different needs. Imagine a company that collects product usage events, customer support tickets, and financial transactions, and executives expect a consistent monthly performance dashboard. The raw usage events might land in a lake because they are high volume and arrive in varied shapes, while financial transactions might be curated into a warehouse because accuracy and stable definitions are mandatory. A sales team might use a Mart that presents simplified customer and revenue tables tuned for their reporting, derived from the warehouse so they share definitions with finance. Meanwhile, data scientists might explore raw and semi-structured data sets in the lake to develop new features and models, then publish curated outputs into the warehouse for broader consumption. This story shows that repository types are not mutually exclusive, but each serves a role, and trouble begins when the boundaries and definitions are unclear. Silos can be recognized as isolated stores that block shared truth, even when each silo is technically well managed for its local purpose. A silo might be a department's private database, a set of spreadsheets on a shared drive, or a separate analytics platform that is not aligned with enterprise definitions. The main signal of a silo is not the technology, but the lack of integration, shared governance, and shared metric definitions across the organization. Silos create friction because teams spend time reconciling numbers instead of improving decisions, and leadership loses confidence when reports conflict. Exam questions often describe situations where marketing and finance disagree on revenue, or operations and product disagree on active users, which is usually a symptom of siloed data and inconsistent definitions. Recognizing silos as an organizational problem, not just a storage problem, helps in selecting answers that restore shared truth rather than creating more parallel systems. Duplicate metrics often appear when marts drift from warehouses because the same measure is recalculated with slightly different filters, time windows, or definitions. Drift can happen innocently when a team tweaks logic for a local need, and then that logic becomes embedded in their dashboards and scripts. Over time, those differences become institutional, and people stop noticing that the same metric name does not mean the same thing across teams. The result is that meetings become debates about whose numbers are correct, and energy shifts away from decisions and toward reconciliation. On the exam, a STEM that mentions inconsistent KPI definitions or multiple sources of truth often expects recognition that duplication and drift are the root issue. The best answer usually involves centralizing definitions, aligning marts to a governed model, or improving lineage so that differences are visible and intentional. Balancing cost, performance, and control requires clear priorities because optimizing all three at once is rarely possible. Lakes often offer lower storage cost and high ingestion capacity, but they can require more effort to achieve consistent performance and strong governance for many users. Warehouses often offer strong performance for analytics and consistent definitions, but they can cost more in engineering and may require structured pipelines to keep them current. Marts can improve performance and usability for specific teams, but they introduce maintenance overhead and governance risk if they are not aligned. Lakehouses aim to reduce duplication and combine benefits, but they still require careful operational discipline and cost management. The exam typically rewards the candidate who identifies the dominant priority in the scenario, such as trusted reporting, rapid ingestion, cost sensitivity, or tight access control, and then chooses the repository approach that best matches that priority. Architecture choices should be driven by access patterns, not buzzwords, because access patterns determine whether the repository will actually support the work being done. If many users need consistent dashboards and repeatable metrics, the architecture must support shared definitions and stable query performance. If a small group needs exploratory analysis on raw and varied data, the architecture must support flexible ingestion and diverse formats without slowing down every new idea. If the work is event-heavy and time-critical, the architecture must support frequent refresh and fast retrieval of recent data, often with careful partitioning and indexing decisions. Exam stems often include clues about who the users are, how often they query, and what they expect from results, and those clues matter more than the repository label. Choosing based on access patterns is a professional move because it ties design to real behavior rather than to trend following. Ingestion and refresh rhythms matter because a repository that is correct but stale can be worse than a repository that is approximate but current, depending on the decision being supported. A warehouse dashboard that updates monthly might be fine for executive reporting but useless for operational monitoring. A lake that ingests continuously might be valuable for near real-time exploration, but confusing for executives if definitions are not stabilized before reporting. Marts often have their own refresh schedules, and misalignment with the warehouse can create temporary inconsistencies that look like errors if timing is not communicated. Exam scenarios sometimes mention yesterday's data, late-arriving records, or out-of-sync reports, which are often refresh rhythm problems rather than calculation problems. A thoughtful architecture includes not only storage, but also the cadence of movement and the expectation of freshness for each audience. A practical selection habit can be summarized as 4 questions that guide repository choice without relying on memorized slogans. One question is whether the primary need is raw capture and flexibility, or curated consistency and shared definitions, because that separates lake-like goals from warehouse-like goals. Another question is, who the audience is, and how many consumers need stable metrics, because broader consumption tends to require stronger governance and a clearer contract. A third question is what the access pattern looks like, including query volume, latency expectations, and whether the work is exploratory or repeatable, because that drives performance and schema decisions. A fourth question is how definitions and lineage will be maintained across time, because trust depends on being able to explain where data came from and why numbers match or differ. Holding these questions in mind turns repository selection into reasoning about consequences, which matches the exam's intent. To conclude, repository choices matter because they shape how quickly data can be captured, how reliably it can be queried, and how consistently it can be trusted across teams. Data lakes emphasize raw and varied low-friction storage. Data warehouses emphasize curated, structured, query-ready storage. Data marts emphasize focused subsets for one audience. And lakehouses aim to blend lake flexibility with warehouse management features. Silos are not a formal repository type so much as a failure mode where isolated stores block shared truth and create endless reconciliation work. Governance expectations, schema discipline, refresh rhythm, and alignment of definitions determine whether marts and other downstream views support trust or create drift. One useful practice is to pick a familiar reporting need and state aloud which repository approach fits best and why, naming the dominant priority such as flexibility, trust, performance, or control, because that habit mirrors the exact reasoning that the exam is designed to reward. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.